Okay, hello everyone. I am going to try and explain 3.4, 3.5, and 4.3 better. We're going to start with 3.4. I'm going to try something new. I think it should help. We'll see how it goes. Before I wrote on these papers instead of working it out on the computer. You can't see that at all. And I think that bouncing back and forth made it harder to understand. So I'm going to help y'all with that. But that also means I'm going to try and use a whiteboard that's on the computer, and that might suck. We'll see how it goes. So let me go ahead and share that. I'm going to throw my camera over to this screen and share. So I'm hoping y'all can see both the homework and the whiteboard, and I hope this goes as planned. So the first thing I want to point out on this, when it's f of x equals x, is that, oh no, f of x, this could be tragic, equals x, is the same as y equals x. So whatever we put in for x is going to be the same as y on this one. So if we have this table 0, 1, 2, let's go ahead. So if I put 0 in for x, that means y equals 0. If I put 1 in for x, then that means y equals 1. If I put 2 in for x, it's an awful 2, that means y equals 2. So this graph is our linear function, and it's 1 to 1. So whatever we have for x, it's the same for y. It's awful. So when x is 0, y is 0. When x is 1, y equals 1. When x is 2, that means y equals 2. So then when we go to graph this, our ordered pairs are what we just put into this. So when we have x 0, y 0, 1 to 1, 2 to 2, but since it's a straight line, when we graph a straight line, you only need 2 points, and we have our 2 points right there, so we don't have to do anything else. This one, it's the same graphs you graphed in chapter 2. It's just now we're using our function notation more, and we're going to rely on our function notation because our next chapter is going to be shifts and transformations using this function notation. Okay, can I just erase this? Okay, so now then our function is changed to f of x equals x squared. Maybe I'll get good at this by the time we get through this. I like that too. Remember on this one, when we have x squared, that means there's 2 x's. So this is also, put a big line, haha, x times x. My sound effects on this video is going to be crazy because I'm learning how to do this. So this would be the same as y equals x squared. So when we go to put these into this table, and I'm going to write this table a little different if it works out for me, because it's the same as these input-output tables you used to use. So we'd have x, we'd have y, and we're going to have, I'm going to write it backwards, x squared equals y. And they gave us -1, 0, and 1. So when we go to plug these into this input-output table, we're going to have our -1 squared, which would be -1 times -1. And that's what I'm going to write here. -1 times -1. And we know a negative times a negative is a positive, and if we have 1 times 1, we would have a positive 1. We could also use different numbers to put into these, just like in our input-output tables. It doesn't have to be these, except it does for this problem because these are the ones they wanted us to fill out for. If we did -2 into this one, we'd have a -2 times -2. A negative times a negative is a positive. 2 times 2 is 4. So if we put -2 into this function, we would get positive 4 out. Now here, if we did 0 squared, it'd be 0 times 0, which would give us 0. If we put 1 into this function, 1 squared, 1 times 1 would give us 1. So then we look at our x and our y values. So we'll have that point -1, 1, 0, 0, and 1, 1. If we wanted to extend on this, if we did 2 squared, we'd have positive 4. So we already did -2. So we know also on this graph, we could have the point -2, positive 4. We could have the point -1, positive 1, 0, 0, 1, 1, 2, 4. We know if we went ahead and did 3, we would have 3, 9, and so on and so forth. So on this one, we just have to put in the ones we have in the table. So -1 squared is a positive 1. 0 is still times 0, so it's 0. 1 times 1 is 1. Now, if you remember factoring in quadratics, it's always when x is squared. So one thing about this, you can hover above them. A line tool, ours is not a straight line because it's x squared. Whenever we have x squared, it's a parabola. 3-point quadratic tool. This is a quadratic, so that's what it is, absolute value. This one is a cubic tool, so when it's raised to that third power, it's considered a cube in a circle, but we skip the section on circles. So -1, 1, 0, 0, and 1, 1. If I wanted to go ahead and check it for my 2, I could. If I was at 2, we would have that 2 to the 4th power, so we could go on up, and we see that it crosses at 2 to the 4th power. If we did 3, 3 times 3 is 9, so we could see that it crosses right there at 3, 9 as well. -2, positive 4. So this would be our graph. I hope that makes sense. But this is the one I get all the questions on. So I'm going to try and do better at explaining this one. So f of x equals x cubed. Oh, help. Worst 3 I've ever made. Okay, so just like the other ones, this would be the same as y equals x cubed. It's a better 3. When we have x cubed, that would be the same as 3 x's. So x times x times x. And then we'd go ahead and we'd plug those into this. So we'd plug the values of x that they gave us to get our y value. There is a trick to this one. Go ahead and put y over here. I don't know what happened right there. So x cubed, we're going to have x cubed gives us I. And they gave us negative 1, 0, and 1. This one relies on you to be able to differentiate different functions. And without knowing, well, you should be able to tell. This is f of x equals x cubed. It should not look like a function we've already done before. So if we put negative 1 in here, we'd have negative 1 times negative 1 times negative 1. So a negative times a negative is a positive, times a negative would give us a negative. And 1 times 1 is 1 times 1 is 1. Here, if we go ahead and do 0, 0 times 0 is still 0, times 0 would give us a 0. A pair. 1 times 1 is still 1, times 1 is still 1. Now right here, if we go ahead and plug these numbers in, and let's do it because I can keep them side by side and show you. We have negative 1, we have 0, and we have 1. So if I know that x is raised to the third power, I know that means it's a cube. So I would use this cubic tool. And if I graph these points, negative 1, 0, 0, and 1, 1, it's a straight line. I'm not using that cubic point. Go ahead and line it up. That right there is still f of x equals x, y equals x, because the values I put in, they line up. Negative 1, 0, 0, 1, 1. That's not a cubic graph. That's f of x equals x as of right now. So to be able to graph this one, we're going to need another point. It doesn't matter which number you choose for the other point, as long as you can graph it. So if we wanted to use the two that you can graph on this one, since they go to 10, I'm sure you could graph the other ones. It's just not going to be as easy. It's going to be negative 2 or 2, because this graph only goes to 10. And if you did 3 cubed, 3 times 3 is 9, times 3 is 27. That goes off this graph. So let me extend these. So I have negative 2 times negative 2. Negative times negative there, that's positive 4 times negative 2. So I can make it 2s. 4 times 2 is 8. Negative times a positive would be a negative 8. Then if we did positive 2, we'd have 2 times 2 times 2. So 2 times 2 is 4 times 2 would give us a positive 8. You can graph either one of these points, but if you notice right here when you hover over it, it's a 4-point quadratic tool for a reason, or 4-point cubic tool for a reason. And we use the cubic tool because this is a cubed graph. So if I needed to finish this graph, I'd have to graph 2, 8 or negative 2, negative 8, because 327 is not on this graph. And you can't just pick a point. You can't do 2, 6 or 2, 10 because that is not correct. Because 2 to the third power is not 2, is not 10. 2 to the third power is not 6. It has to be 2, 8, because that's the only way it's going to be cubed. Trying to think how to make that make more sense. Because as of what they gave you right there, that's a straight line. That's not a cube graph. To graph a line, you only need 2 points. To graph x squared, you only need 3 points because we had our -1, 1, 0, 0, 1, 1. We could have done -2, 8, 0, 0, and 2, 8 because there's no negatives when we have that x squared, because if you tried to change that graph and solve it for x, it's not going to be how do I want to say this? If we solved it for x, we'd have the square root of y squared. I'm going to stop while I'm ahead because I think I'm going to make it more complicated. I can talk more about it. I just don't want to lead y'all down a rabbit hole of stuff that I know that you don't need to know, if that makes sense. So this one, we have our square root function, f of x equals the square root of x. So that's going to be y equals the square root of x. Remember back to lesson, I can't remember if it's 1.3 or 1.4, where they talked about imaginary numbers. We can't graph imaginary numbers, so there's not a negative that's going to be under that square root. So it's only going to be in the positive values unless they give us a negative over here, and they do not. So let's go ahead and throw some numbers in this, because the easiest way to check is to substitute numbers. So let's put 0 in here. Since it's the square root of x, I'm going to do 0, 1. Let's see what they have going on, and 4. But like I said a second ago, we can't have negatives, because if we take the square root of a negative, it's an imaginary number. So B and C would already be out, because we shouldn't have anything on the negative x axis. But we can on the positives. So we just need to know the square root of 0 is 0. They all have 0, 0. I shouldn't have picked that number. If we did the square root of 1, it's positive 1. If we did the square root of 4, it's positive 2. I remember the square root is the opposite of a square. So 1 squared is 1, 2 squared is 4, 0 squared is still 0. So this one, we'd be looking for the point 0, 0. They don't have 1 on here, but it'd be 1 positive 1. This one would be in the negatives. This one is in the positives. And then we'd have 4 positive 2. This one isn't an option because it has negatives. When you take the square root of a negative, it's an imaginary number, and we cannot graph an imaginary number. This one, they're saying they took the square root of 4 and it came out -2. That's not happening unless they gave us a negative with there would have had to be a negative right here in the front, because then the square root of 4n would give us -2. But they do not. They did not reflect this graph. You'll learn more about that in the next section. Oh, reciprocal graph or function. I'm about to stop this video and start a new one so it don't get too long. So this would be y equals, the first thing on this one that I'd look at is 0 couldn't be in this one, because if I had a 0 in for x, it would be undefined. So I'm going to make that note. We have x and y. 0, it cannot equal 0. Because if we have 0 on the bottom of a fraction, we can't divide by 0. So that would be undefined right there. So these that have a value at 0 aren't options. because it's undefined at that point because you cannot divide by nothing. So A and C cannot be options. Then let's go ahead and say if we put 1 in, if we do 1 divided by 1, we'd still have 1. So we should have that 0.11. This one does. If we wanted to go ahead and check, since they have that -1 there, if we put -1 in, and I'm going to go ahead and write right here, this would have been 1 over 1, and this one would have been 1 over 0. I'm going to put an equal sign up there because you can't divide by 0. That would make it undefined. You can't divide by 0. Type it in a calculator if you don't believe me. Or go try and divide your pi by 0. Like literal pi. Go try and cut your pi up by zeros. It makes no sense. Okay. Then here, this one would be -1 because we would have 1 over -1. A positive divided by a negative gives us that -1. So then we can check with that as well. We already know this one's our graph, but this one, they had that -1 value in it, so I wanted to go ahead and check it. So if we put -1 in, we would not get a +1, we'd get a -1. Whenever you're confused with these, just go back to your basics, plug in some numbers and check them. But go ahead, if you have the time, and plug in the values or make flashcards, because we're going to use these a lot. So if you can put the graph on it and say what that function is and have the back of the function, like this wrote out, have the graph on one side and the function wrote on the other side so you can recognize them, because you're going to use these for this chapter for sure. But we use what these functions are to determine the ends of the graphs on the next chapter. All right, I'm going to go ahead and do this one, so we'll be halfway through. F of x equals the absolute value of x. So when you look at absolute values, remember that they're always positive. Absolute values are always positive because they are a distance. That's how I explained it to the middle schoolers when I taught there. An absolute value is a distance, and you can't have a negative distance. If you're 6 feet under, it's still 6 feet. So absolute values are always positive. They're happy little lines, and anything that comes out of them is positive. So let's go ahead and get us some points. Since they're always positive, we're going to need a negative value or 2 to throw in here. Because if I just go with the positive values, I'm just going to have this straight line. So whenever you are graphing these, I'd go ahead and pick a negative and a positive on all of them. And on this one, I don't want you just to do -1, 0, and 1, because that would be the same as your x squared. So you need to, I'd always check -2, 0, and 2 on these graphs to determine what you have to do. Because when you just do -1, 0, and 1, you're going to be tied up in just getting 1s and 0s. Because it doesn't matter if I square or cube that -1, I'm still going to end up with 1. It's just might be negative, it might be positive. But if you use 2 on all these, if we think of the ones we've just done, so if I did the first one, f of x equals x, if I put -2 in, we get -2 out. If I do f of x equals x squared, if we put -2 in, -2 times -2 is +4. If we do f of x equals x cubed, if we put -2 in, we'd have -2 times -2 would give us our +4, times -2 again would give us that -8. If we put -2 into our reciprocal function, we'd have 1 over -2, which would be a -1/2, but that would still help us. If we put -2 into this one, we're going to get positive 2 out. So that was my spill on using -2 instead of -1 to check your graphs. So right here, what did I even click to get that up? Can you go away? No. So the absolute value of -2, even though I suck at writing 2's on this, absolute value of anything is positive, so it'd be +2. If we did the absolute value of 0, 0 is still 0. If we did the absolute value of 2, it's still +2. So the reason I say to use 2 on this one instead of 1 is because if we would have used 1 and give us the same stuff we would have got if we were using the x² function. So right here, -2, +2. We have it here. There's nothing here. These both have -2, -2. This one would be the correct graph if we had a negative in the front and it flipped it over. Otherwise, there should be nothing negative on this except for x values. Okay. This is another one though. -1, -1, 0, 0, and 1, 1. Use your 2's to figure it out. Which it's going to be ugly on this one. But if I do the cubed root of -2, it's going to give me some crazy decimal. Can I do that on a calculator on this? I used to have one that was... The cube root of 2. Try again. Is 1.2599. So the cube root of 2, and that was +2, is this 1.2599. So if I look at this one, it's a little above 1, so that's good. This one, it's in the negatives, so it wouldn't be. This one at 2, that doesn't have the graph there at all. This one at 2, it goes up too far because it's not at 1.2599. So I could use 2 on this one. And then if we went ahead and let's say -2. Okay, second cube root, it'd be -1.25999. So right there, it'd work here. The pretty numbers on this one, you'd have to think of the opposite of a cube. So if I did 2 cubed, I'd have 8. So if we did 8, we'd get that 2. But it doesn't show that for us anyway. It goes to 5. So I guess I could have done 5 cubed root as well and got 1.7. So it's still going to be less than 2. And you can see that on these. This one would be correct if it was negative. This is our x cubed function, and this is our negative x cubed function. Just plug them in and check them until you get used to seeing them, and then revisit. All right. This graph right here, since it's f of x equals -4, I want y'all to remember that f of x is the same as y. So this graph, I hate writing with this. F of x equals -4, yay, would be the same as y equals -4. And that's that horizontal line where y is always -4. So horizontal line, go to -4. That's where y equals -4. And that's the only thing that's not going to change on this graph. It's constant. y equals -4. Okay, I'm going to definitely stop this video now. Not what I meant to do. Where is it?